So when you're working with the sum and difference formulas in Trig, I like to think of the sign as being a little quick short story. Okay, I'm the oldest of 5 kids. Okay, 2 sisters, 2 brothers in that order. Okay, the middle sister, the second sister, is the peacemaker. Okay, she's a peacekeeper. She played with both I and my younger sister Christy, and got along with everybody, and she just went with the flow and was wonderful. Okay, my younger sister Christy was hellfire, I guess, if in a bad, not, she wanted her way, and by golly, she was going to get it type thing, so and it was just an interesting dynamic. Okay, love them both, get along with them great now, but as growing up as kids, there were battles about who had to do the dishes and who had to fold the clothes and who had to, set the table and so forth. So it was always a fight. Okay, so I think of the sign as being like my sister Carrie. Okay, she's the peacekeeper. She takes turns, right? So the sine of u plus v is sine of u cosine v, and she's even keeping the sign the same, right? Plus cosine u sine v. Okay, and sine of u minus v, again, taking turns, keeping things on a nice even keel, right? Sine u cosine v, same sign, minus cosine u sine v. Okay, so I think of the cosine like my youngest sister. Okay, she wants to be first. She wants, to dominate things and so forth, right? Very, very strong personality. So cosine u cosine v has to get their part first. And then let's just be a little contrary and change the sign here, right? And make it a minus sine u sine v. Okay? And then the cosine of u minus v would be cosine u cosine v again. Cosine gets to take their first piece of the cake, right? Then change the sign on things and then say sine u sine v. Okay? Now, tangent, he's like my brother Ryan. Okay? My brother Ryan has 9 children. They are all, I think, 10 and under, maybe 11 and under, and no multiples, right? So he does things kind of crazy, just like tangent, right? Tangent doesn't look like sine or cosine. It doesn't look like secant or cosecant, right? It just kind of does its own thing. I don't know. I really don't. That's a lot of kids. Yes, yes. Yeah, yeah. And they homeschool, so they don't even go to school. I know, I know. I- I don't know that they have a computer. They live on a farm with no internet access. So, okay. Anyway, for another discussion. Okay, so for another discussion, okay? And I don't want my siblings to hear this video, so whatever you do. Okay, so anyway, here we go. So the tangent of u plus v, okay? He has to have a numerator and denominator, right? Because he's dealing with sine and cosine. He's got something on top, something on the bottom, right? And so the tangent of u plus v is tangent u plus tangent v, okay? Keep the sign the same, okay? But then when you divide, you're going to take one opposite sign, tangent u times tangent v, okay? And if you're taking tangent u minus v, still tangent u minus v, keep the sign the same, but then when you divide it and you take one, you're going to do plus tangent u times tangent v, okay? Most likely. All right, so here's what we're using these for, okay? Um, we could, absolutely, okay? But I don't want to take the time, okay? All right, so here's how we use this, okay? If they ask us to find, or if I ask you to find the exact value of the sine of 15 degrees, that means I don't want a decimal equivalent. I don't want you just to plug it into your calculator, making sure you're in degree mode and figure it out what it is, okay? What I want you to do is to use your sum or difference formulas, right, to help figure it out. So the only ones that we have memorized are things like 30s, 45s, and 60s, right? So there has to be a way to get 15 from 30s, 45s, and 60s by either adding or subtracting. So how would we get 15 from those special angles that we know? Okay, we could divide by 2, right? We could take the sine of 30 and 30 over 2, right? But that's going to be called our half angle formula. We're not going to use that until next week. Okay, so I like it. So we could take the sine of 45 minus 30. Because that's the same thing as the sine of 15, right? Okay. So remember, sine's nice. It says, let's take the sine of 45. As long, you bet. You could have done 60 and 45 instead. Okay? Absolutely. You'll get the same answer. Okay? So sine's nice. It's going to take turns with cosine, right? So we're starting with the sine of 45, and then the cosine of 30. And it keeps the same sign that it had in the parentheses. So minus, now it says sine 30 cosine 45. Okay, it's the peacekeeper, the one that takes turns. It does, because the 45 is my u. So when I said sine, I have to use the 45 first with the cosine of 30, and then the sine, or the cosine of the 45. Sorry, I just wrote it the wrong way. This is actually supposed to be, remember we had this earlier, sorry. This should be the cosine, or the sine of v cosine u. Is that not what you had written? I have it right up here. I just wrote it wrong here. Okay, my fault. It's the same thing. So we're going to have cosine of 45 sine 30. Okay? Sorry, I didn't mean to confuse you. Okay? All right, so far so good? Now what is the sine of 45? Root 2 over 2. What's the cosine of 30? Root 3 over 2. Cosine of 45? Sine of 30? Okay? Now, when you have radicals, it's the same radical, both a square root. We can multiply what's inside, right? We can't add them if they're not exactly the same, but we can multiply what's inside. So we'll have a square root of 6 over 4 and a negative square root of 2 over 4. So if you want to tighten it up and write them over the common denominator. And unfortunately, once these guys they're two separate, think of them as variables, right? They can't be added or subtracted. They can be multiplied to be combined together, but they can't be added or subtracted unless they're identical. Nope. So we just call it square root of 6 minus the square root of 2 all over 4. Okay? There's no perfect square in it. It's a 2 and a 3, but it's not. That would have to be 8, not 6. Yep. Um, we'd have to have something to square on the other side. So if we square this side, that's like saying that we're squaring the sine of 15. Okay? So that's your whole answer. Okay? It's different. Okay? All right, next one. Exact value of the cosine of 7 pi over 12. Yep, the answer for the last one was root 6 minus root 2 over all over 4. Okay, so now we're working with the cosine of 7 pi over 12. So now we're throwing a radian at you, and you don't recognize that radian measure, right? Okay, so what can we do? Change it to degrees, absolutely. Okay, so if we're going to convert this to degrees, 7 pi over 12, 180 over pi, and 12 and 18 at least have a 6 in common, right? So we'll have a 2 and a 30. And they have a 2 in common, 7 times 15, right? What's 7 times 15? 105. So we have 105. Okay? So here's another way of looking at it, though. Okay? 7 pi over 12, right? We have pi's over 3, pi's over 4, pi's over 6's, right? Okay? Which would have a common denominator of 12? 45 and 60, right? Because a pi over 4 and a pi over 3 can get us a pi over 12, right? Okay. And so if we get a common denominator of 12, this one has to be taken times 3, and this one has to be taken times 4, and we would add them. So that is 7 pi over 12, right? Okay. So I'm sorry, back to your question. Okay. Pi over 2 and pi over 6 would be a pi over 2, pi over 6. That would get us 6 pi over 12 and 2 pi over 12, right? So that would be 8 pi over 12, not 7 pi over 12. So we have to try to get a 12, right? And pi over 6 and pi over 2 could get us a 12, but it ended up being the pi over 4 and the pi over 3. Yes, sir. Mm-hmm. Mm-hmm. Okay. Because we were taking a 45 minus a 30, and it was the sign. So once we recognize that it's a minus sign, we're having to subtract them, and we're using the sign, then that sets the formula that we're using. Because how would we get 15? We had to, if we added them, we get 75, right? So when we subtract them, we get 15. So, but like you said, we could have also taken 60 minus 45, right? And gotten the same thing, right? But we don't know 5 and 10, right? So we have to use the 30s, 45s, and 60s that we know, okay? We're kind of restricted in what we can work with, okay? All right, so far so good? Good questions. Okay, so do you want to continue on in degrees or do you want to work in radians? Degrees, okay. So how are we going to use 30s, 60s, and 45s in some combination of adding or subtracting to get so 60 plus 45, okay? So by saying plus 45, now we're having to use the cosine plus. Yep. So the cosine was here, right? Okay. Yep. So that's why. So we recognize that we're taking the cosine of 30, or I'm sorry, 60 plus 45 to get 105, right? Doesn't matter, and when we're adding, right? As long as we're consistent. So if you wrote 60 plus 45, we're good, or if we wrote 45 plus 60, okay? We're going to get the same answer either way, okay? As long as we're careful with our formula. So did everybody write 60 plus 45? Okay, so here we go. So our formula says, okay, this is the bossy one, right? That wants their fair share first. So we're going to take the cosine of 60 times the cosine of 45, and then we change the sign in the middle, and we do the sine of 60 times the sine of 45. Okay? So what is the cosine of 60? What's the cosine of 45? What's the sine of 60? What's the sine of 45? Okay, so when I multiply these together, I get root 2 over 4. And when I multiply these together, I get square root of 6 over 4. Almost. Exactly. Yep. Because you won't get the same thing. Now, how would you test this to verify that you did it right? If you plug this into your calculator, you're going to get a decimal, right? Okay. Make sure your calculator's in degree mode in this case, right? And say, what's the cosine of 115? 105. So once you have the cosine of 105, that number should match whatever you get here. Okay? Make sense? All right. So you ready for my wild and crazy brother? Not yet? My wild and crazy brother? The one with all the kids? But do you see how the silly stories yeah, do you see how these silly stories though help you remember things and help you kind of sort things in your brain? And that's the only reason I even mentioned it. Okay? So now we want the tangent of pi over 12. Those you'll use enough that you'll memorize them. That's the plan anyway. Just enough homework that you get them memorized, but not too much homework that you're working for days, right? All right, so you can turn it into degrees first, but just a moment ago we found out that where we're dealing with pi's over 3s and pi's over 4s, right? Okay, so yeah, pi over 3 minus pi over 4, let's see what we get. I wrote that really large. Well, a moment ago we said that pi over 3 and pi over 4 gives us a pi over 12 in some way, right? Okay, so let's see what happens here. If I multiply this by 4 over 4, I get 4 pi over 12, right? And if I multiply this by 3 over 3, I get 3 pi over 12. So 4 pi over 12 minus 3 pi over 12 does get me a pi over 12. Okay? So do you want it in degrees? Okay, we can work it in degrees. So we want the tangent of, so we know we're taking a pi over 3 minus a pi over 4. What's pi over 3 in radians? Degrees? So, yep, 60 degrees minus pi over 4 is 45. Okay? And if we had converted 11 pi over 12 to degrees, we'd get 15 degrees, right? Okay? All right. So I don't want to confuse anyone, but we could work this completely in radians and not have to convert it to degrees, right? But if you want to convert it to degrees, if we take pi over 12 times 180 over pi, we end up with 15 degrees. So we have to use 60s, 30s, and 45s in some way to get 15 degrees, okay? So 60 minus 45 gets us 15 degrees, right? 45 minus 30 also gets us 15 degrees, right? So we could use that as well if you'd prefer, okay? So far so good? All right, haven't lost anybody. All right, so here comes that wild, crazy brother. And if we're using a tangent of u minus a tangent of v, and that means that we're taking the tangent of the first minus the tangent of the second over 1 minus the tangent of the first times the tangent of the second. So tangent of 60 minus tangent of 45. Sign stays the same on top, but it changes in the denominator. 1 plus tangent of 60 times tangent of 45. Okay? All right, so tangent of 60 is what? Square root of 3. Tangent of 45. 1 plus, what's the tangent of 60? And what's the tangent of 45? All right, so we're almost there. Yes, sir? Mhm. Absolutely. You could have said instead of this, the tangent of 45 minus 30. That's another way of getting 15. Okay? And we can work that one too to show you get the same answer. You just did. Okay. So now, one slight problem. We never like to leave a radical in the denominator, right? So what are we going to do to make that radical go away? Okay. So how are we going to get the square root of 3 on top and get rid of it on the bottom? Multiply by what? If we multiply by 1 plus radical 3, what's going to happen? We'll get that double angle thing in the middle, right? So we have to multiply by its conjugate. Okay? So when we do that, we'll have a square root of 3 minus a square root of 3, right? Minus first times outside is going to be a minus square root of 3 squared. Inside is going to be a negative 1. And last is going to be a positive square root of 3. Okay? Denominator, 1 times 1 is 1. Outsides and insides go away by design because we used exactly the same thing but a minus sign, right? And last times last will be a negative square root of 3 squared, or negative 3. So, in the numerator, square root of 3 squared is 3. So we have a negative 3 minus 1. And then we have a square root of 3 plus a square root of 3. Good. And then in the denominator, 1 minus 3 is, so to tighten it up one more time, divide everybody by that negative 2, right? So 2 plus minus a square root of 3. Because we'll change the sign of the second term. Okay? All right, and then we could verify. We could plug 2 minus the square root of 3 into our calculator to see what we get as a decimal. And then when we can take the tangent of 15 and see what we get as a decimal. And they should be the same, as long as we're in degree mode. Okay? Question? I saw someone hand. Oh. Okay. Did you want to see that tangent 45 minus 30 gets you the same thing? Or you feel comfortable and confident that it's okay? All right. Awesome. All right, so here comes the assignment. And that's what I was expecting you to say. Okay? This is a 2-day assignment. Okay? We're starting it. Try to do the stuff in blue today. Okay? And then the stuff in black will be what we talk about on Monday. Okay? This is a 2-day assignment, or several day if you consider the weekend. Okay?